Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore one very popular framework for data quality checks, and that is PyDQ. So in data engineering world there is a very popular saying that GIGO, garbage in garbage out. So it is like if your data is not having good quality, if it is having some wrong value, then no matter whatever transformation you apply, in the output also you will be getting garbage data, and based on that particular outcome, if you take some business decision, that might lead to huge loss for the company. So having a very good quality for our data is very vital for any data pipeline. Now the question is there any framework using which we can check the quality of our data? And obviously one of the most important feature what the framework should have, that it should able to handle very large volume of data, right? Because nowadays in almost all the organizations we are having huge volume of data sitting in our data lakes. So how we can apply data quality checks on those data, and if there is some issue or discrepancies with that data, we might need to go back to the source team to rectify that issue, right? So to solve these kind of problems, there is a very beautiful framework which you can utilize along with PySpark to basically apply data quality checks on a large volume of data, and that is PyDQ. So just a very little theory on PyDQ. So it is an open source data quality library, addresses data quality monitoring requirements, and can scale to large data set. This is its beauty, that you can work with this particular PyDQ and PySpark to apply data quality checks on a huge volume of data. Okay, DQ is built on top of Apache Spark to define unit test on data. So generally we do unit testing on our Python code or Java code, whatever code we are using in our data pipeline, right? But using this framework, we can apply unit test on the data itself instead of applying on the code. For code application, whatever method we follow, that is different. But this is to apply unit testing or quality testing on our data. Okay. With DQ, you can populate data quality matrices and define data quality rules easily. So obviously this should be the feature of this particular framework, and that's why we are starting it, right? Now here I have given two links, one containing the documentation which is in PDF format. You can download it and go through this to explore about all the different functions and methods in detail. And also I have provided one particular link here which contain the currently supported functionalities or what kind of checks this PyDQ can apply on our dataset. Okay, so here we are having bunch of list that what kind of checks we can apply. I will go through most of these with PySpark examples. Okay, right? So as a first step, what we will do, we will complete the installation. So here I am basically running my code in Google Colab, and by default in Google Colab we don't have Spark. So what I will do, I will install Spark. Okay, and while installing Spark, just make sure the Spark what you are installing that has PyDQ compatibility, because PyDQ, this particular framework, is not compatible or does not work with all the Spark released versions. Okay, but for most of them it works, and I will show you how we can work with that in AWS Glue or other AWS services as well. So let's focus on this Google Colab notebook first. As a first step, what I will do, I will install Spark 3.1.1. okay, and here let it get installed. So once the installation will be completed, here we will able to see this particular tgz file. Okay, and then as part of the next step, here we are unzipping that particular zip file, so that way we should be having a folder with this particular name in this directory. So let's refresh, and here if you see, we are having this tgz zip file, and here it got unzipped, which contain all the subfolders within it. Now as part of the next step, what we need to do, we need to configure these two environmental variables, that is Java home and Spark home. So Spark basically we installed in this directory only, which is our content folder. If you want to double confirm, so here you can just write pwd, and here you will see /content. So that's why we are defining Spark home as content / this thing, and Java home basically wherever Java is installed. So I will execute this command as well, and then we are using find Spark, we are initializing it, and we will install PyDQ, and PySpark we will be installing also for 3.1.1, because Spark here whatever we have installed, that is basically 3.1.1, right? So here I will install that also. And if you are using AWS Glue or EMR, then by default PySpark and all these things will be there. So this is done. And one more variable we have to define, that is Spark version. So here the Spark whatever we have installed is basically, if you see here, 3.1.1, right? So that's why here Spark version we are defining 3.1.1. This is required for PyDQ. Okay. Now PyDQ Python module we have installed using pip installation command, but we need a jar file also to work with PyDQ and Spark. So for that, here I have written the code. Obviously we are importing Spark session and importing PyDQ, whatever we have installed using pip install command, and here the modules or jars whatever is needed to run PyDQ along with PySpark, that we are installing. That is using dot packages, we can install that in runtime, right? So while creating this Spark session itself, we are executing these packages and exclude command to install the necessary jars. Okay, so let me execute this particular cell also. So these are just related to installation. This is not our main focus. So in this video, our main focus will be how to perform data quality checks using PyDQ. Okay, so to do that, we need to go through these installation steps. That's what we have done here. Okay, now here if you see, we are creating a Spark data frame which contains some dummy data. And let me execute df.show to show you that data in a data frame. So here we are having this data set like this: A, B, C, D, E, F column, where A is string, B, C, D, E, F are basically integer type column, where B is completely filled, it is not having any null value, but C, D, E has null values, and if this column contain some negative number also, just to make sure it will contain all the possible cases whatever we are going to cover for data quality checks. I have created this data frame like this. Okay, now here these PyDQ imports we need to do. So from PyDQ checks import star, so all possible checks whatever currently get support, that we are importing, and from PyDQ verification import star also we are doing. So this will help us in verifying those predefined data quality rules on our data frame. Okay, and here we are creating an object check for the check class. Okay, if you go through this particular GitHub documentation, here you will see that we can create a object for our check class, and it will contain Spark session, level, description, and constant. So this feature is currently supported, that's why status is done. If currently any feature is not supported, then here it is showing some different status like not planned or planned, not implemented, something like that. But here we are considering only done features which are now in production. Okay, so first step what we need to do, we need to create an object for the checkbox. So that we are doing. First we need to pass the Spark session, then what level of alert we want to get, so that we want to get just warning, and here we are giving some description like basic check, right? I hope you got it. Now let's go to the next step. So let's start with a very basic check, and that is data frame number of rows or count of rows in a data frame. So to perform count or size validation, we are having a method called hasSize, and this is already implemented. If you check this GitHub link, here it is written that status is done. If you want to know detailed explanation about this particular validation technique, you can just search in this documentation, and here you will be getting that what it basically does. It creates a constraint that calculates data frame size and runs the assertion on it. So in simple words, it basically helps us in checking whether the data frame is following the size what we are expecting or not. Maybe suppose for a particular data frame, we are expecting that the count should be 4. So that time for that validation, we can write the code like this way. So check result equal to, here you can give any name which will basically store the validation result set, and here we are basically passing the Spark session via verification switch, and on which data frame we want to apply this check, that we can pass using this one on data. Okay, and then we can pass the data frame. The data frame already we have created here, this one. On this we want to check whether it is having number of rows equal to 4 or not. So for that we need to add the data quality check code like this, dot add check. Using this we can add all the data quality check logics, and what we are going to check, we are going to check the size is matching the criteria or not. So check dot hasSize. So this check is basically an object what we have already created here from the check class. So check dot, it is having a method called hasSize, so that we need to pass. And then here we need to pass the condition. So in our case, for this data frame, we are checking whether this data frame is having count of rows equal to 4 or not. So for that, you need to write the lambda expression like this way. So wherever in the documentation you will be facing that we need to pass assertion as argument, that time you just understand you need to write a lambda expression which will basically indicate what you want to check. So here x colon x equal to 4. So this is basically defining I want to check for this data frame whether the size is equal to 4 or not. And then here I have written dot run to run this validation logic. Okay. Now once this validation logic will be executed, what will happen? The result set, suppose we want to read as a PySpark data frame kind of structure. So to convert this result set into a proper data frame, we can basically pass that particular result set via verification result dot check results as data frame method. Okay, and it will basically convert this result set validation logic to a data frame, and that we are printing. Okay, so let me execute this one, and here you will able to see this output. So what different columns signifying, that let us try to understand. So first is check. Check is basically that object what we have created for the check class, and here it is basically defining the description what we have given while creating the object. So here if you see, while creating the object, here we have given basic check. So that's why here it is coming basic check. Then check level. So that is showing here warning, because while creating the object, we have defined check level warning. Okay. Then here check status. So check status is success. Why? Because here this validation logic or verification logic is successful. So it might be possible within add check, we can put multiple validation or verification logic or data quality checks. If all those conditions within this add check block is successful, then overall status it will be showing in check status column. If all those individual checks are successful, in that case check status will show success, or else it will show failure or warning or some other status. Okay. Then here constraint. Now it will basically show individual constraint or data quality logics whatever we have applied. So here in the constraint column it is showing that only that size constraint we are applying. Okay, using hash size. And for this individual condition, whether the status is success or failed, that we will get in the constraint status, that is success. And because it has not failed, so here constraint message we are getting empty. If the condition will be failing, then here we will be getting some message. So let me just add one more condition here only, so that you will get a better idea. So on this particular data frame only, I am applying another condition on the hash size only, that suppose lambda x colon x greater than equal to 2. So what this particular condition is signifying, that we want to check whether for this data frame number of rows is greater than 2 or not. Okay, so I will just run this once, and here I will run this block now, and here you can see one more row we got, and this also successful, because for our data frame we are having 4 rows. So both of these conditions are satisfied. Suppose I am putting this condition x less than equal to 2. So here what we are doing, basically we have applied 2 checks. One is whether it is having the length equal to 4 or not, which is obviously success case, and we have added one extra case, that count of number of rows be less than equal to 2. So this particular condition should be failing, and that time we will see how the row will be coming. So point to be noted, there are 3 vital changes we will observe. One is, because this condition will fail because our data frame is having 4 rows, so in the constraint message it will clearly display that information that this condition is not satisfied for this reason. Okay, constraint status will be failure for this particular check. Okay, constraint name is anyway, this is size constraint only we have applied, and check status will not be success. As I told you, check status will be only success if all the conditions are successful. But here one condition is not successful, so check status will not be success. So check status will be warning, because here we have defined that check level we will just print warning. Okay, so let me just show you that. So here I will run this one, and then run this one, and then run this cell. So here you see that, as I told you, first constant message. So this condition is successful, so for that no message we have got, but this condition is failed for our data frame. So here you can see value 4 does not mean a constant requirement. So in our case, the data frame number of rows is 4, or data frame size is 4, but we have given constant that 4 should be less than equal to 2. This constant itself is not getting satisfied, so it is showing value 4 does not meet the constant requirement. This 4 is coming because our data frame is having size 4. Okay, now this constant status, this is showing failure because this particular check has failed. Okay, constant name is same. Now here point to be noted, check status. So earlier we were getting success because both of the conditions were getting successful. But now because here at least one condition has failed, so check status is not showing success, it is showing warning. The reason for showing check status warning is here we have defined check level as warning while creating the object for our check class, right? So I hope this way you understood the importance of hash size. Basically, this will help us in checking or validating the size of our data frame, whether it is matching the specific predefined value or not. Okay, like here I have written that same case only, that if I run this particular cell, here this will show us failed, because on top of this data frame we are checking whether it is having size equal to 5 or not, whereas our data frame is having size 4, right? So this condition will not be satisfied and it will show the failure results like this. I hope you got it. Now we will be going to our next data quality check, and that is completeness check. So completeness check, from the name itself I hope you are getting, it will help us in validating whether a data frame column is complete or not. That is, it will be useful to check whether a column is having some null value or not. Maybe for example a data frame is primary key kind of thing, it should not contain null value in that case. In those kind of validation, this complete method can help us. So let's see. If I just execute df.show, currently we are having this data frame. So here A column, B column and F column are basically complete. It is not having any null value, but C, D, E are having null values, right? So let's see how to do that check. It is same like earlier. Here we are creating an object for the check class and verification suite. There we are passing our Spark session. On top of our this data frame, we want to apply this constant, and to apply constant within add check, we need to put the object what we have created for the check class, and then we need to call the method dot is complete. So this will help us to validate whether a column in this data frame is complete or not. Now here see, in this method we are passing column name, but earlier in this particular method we were passing a condition. So whether we need to pass some condition or we need to pass the column name, how to know that? So the only way is documentation. So here in this case, if you just search in our PDF file that is complete, here we will get that we need to pass column, we don't need to pass the assertion or condition. Okay, so column in the data frame to run the assertion on. So we don't need to pass the lambda expression here. Here we need to pass the column name, for which we want to check whether any null value there are. And we are applying dot run to run this validation check, and here we are converting that result set into a data frame. We are displaying it. As simple as that. So in this case, we should be getting the result set true, because a column in our data frame, as we have already seen, is complete. It is not having any null value. So that's why it is showing success. Constant name, completeness constant we have applied, and these columns I have already explained how these are coming, right? Now let's see the failure case for this completeness check once. So here if you see C column is having null value. So if I apply is complete operation on the C column, you should see result as failed. Let's see. So here if I run, here you can see check status is showing warning. That means any of one condition at least is not successful. And here we can clearly get that constant, this one is not successful, the status is failure, and here it is giving the message beautifully. Value 0.75 does not meet the constant requirement. So we understood from the manual inspection itself that this constant check will fail. But the question might arise from where this 0.75 value is appearing. So there is an interesting math going on in the backend actually. How it got calculated is, for the C column we want to check completeness. So what it is doing, it is basically calculating the number of non-null values in this column divided by total number of rows available in this data frame, and that value is 1 or not is checked. So here in this case, if you see C column, number of non-null values is 3 and number of total rows are 4. Okay, so 3 divided by 4 is 0.75, that is not equal to 1. So that's why this particular condition is not getting satisfied, and that's how this 0.75 value is coming. So number of non-null rows divided by number of total rows. Okay, that is the calculation approach. I hope you got it. Now here, let me show you this calculation is working or not for other columns also. So let's apply the same is complete criteria on the D column. So D column has two null values. So obviously is complete check will be failing, and this particular value earlier where we were getting 0.75 for C column because it was having only one null value. For the D column, if we apply that same check, what should be the value we get? That is basically number of non-null values. That is, there are two non-null values divided by total number of rows. Total number of rows are 4. So 2 divided by 4, that is 0.5. Okay. But is complete check, his value should be 1. Getting 0.5. So this condition will not be satisfied and will be getting status as failure. And here we will be getting value 0.5 does not meet the constant requirement. So this 0.5 value is coming from this calculation, right? In the backend, what it is working. Number of total non-null rows in the T column divided by total number of rows in this, right? So I hope you understood this, how to do size validation on a data frame as well as how to perform completeness validation on a particular data frame. Okay, so this is all for this particular section. We will catch up in our next section with a new data quality check. Thank you. So the next data quality method what we are going to explore is complete. Okay, and it is quite similar to is complete only. The only difference is complete works on only one column at a particular time. We can basically provide only one column as a input for that is complete method, and it will basically check whether that column is complete or not. That is, that column should not have any null values. Now if you want to implement this for multiple columns at a single shot, then you can opt for complete. Okay, it basically creates a constant that asserts completion in combined set of columns. Okay, that is on multiple columns if you want to check whether they are complete or not. Okay, that time we can opt for complete. So let me show you with the example. So this is our data frame. So now we are applying check.rComplete on A, B. So if you see A, B for both column, no row has null values, right? So this rComplete condition will be satisfied. So let's run it. So I'll just run this code, and here you can see it is giving us success. And even if you check this particular constant column, the explanation itself will be quite intuitive that A is not null and B is not null. Okay, that is A column and B column, for each row none of the cell value should be null. Then only this particular condition will be satisfied and the data quality check will be success. Okay, right? So let's see the failure case as well. So this is our data frame, right? So here if we take A and C column combination, so if you see the first row foo and 5 fine, bar and 6 fine, but the third row BAZ from A is coming but the C is having null value. So if I am putting A, C in this particular rComplete check, then it will be basically failing. So let's verify. And here if I scroll right, here you can see constant status failure. Okay, and constant message value 0.75 does not meet the constant requirement. The 0.5 how it is coming, it is same like what we discussed earlier. I am just reiterating here. So here we are taking A and C column, right? So I will be writing the combination here. So foo and 5. So it is basically 1 because both are non-null. Then bar and 6. So this also 1 because both are non-null. But bar and null. So when we are checking this, although A is non-null but C is null, so when applying the AND condition, we will be getting value 0. Okay, and here A is non-null and C is also non-null. So here what value will be getting? We will be getting 1. Okay, so here if you calculate the ratio, total 3 out of 4 we are getting. So score is 0.75, right? So this is how here this 0.75 value is coming. Okay, it does not meet the constant requirement. I hope you are getting it. In simple way, we can say rComplete basically used to check whether the list of columns are following the completeness criteria or not. And just for your reference, I have explained you how this 0.75 value is coming. Okay, now let's see another example. So df.show if I do, here we are having this kind of data like earlier. Now here is a small task for you. You just pause the video and tell me what output I'll be getting if I am applying rComplete on A, D column. So what will be the status of this check and what value we will be getting in this particular case. Okay, pause the video, try to think about this answer. Here I am explaining. Okay, So here A and D we are applying. So again you can apply simple AND logic. A is not null and D is not null. So first row will be 1. A is not null, D is not null, it is 1. A is not null, D is null. Okay, so here it will be 0. A is not null, D is null. So here it will be 0. So basically 2 out of 4 we are getting, that 2 conditions are getting satisfied out of 4 rows. So 0.5. Okay, but for R complete to pass that condition, we need this particular value to be 1. That is, all the rows should satisfy the condition. For both columns we should have non-null values, but that is not happening here, and this score should be 0.5 in this case. Okay, so let's see. So here if I scroll below and if I run this particular code, so this particular check, as we discussed, it will fail because here D column is having null values, right? And here if you see, the constant message value 0.5 does not meet the constant requirement. So from where this 0.5 is coming? This is coming that way, that AND condition, whatever I have shown you, that explanation, that together in how many rows they are non-null divided by total number of rows. That should be 1 to pass R complete criteria, but that is not getting passed due to null values available in D column, right? So I hope you understood this particular data quality check also. We will catch up in our next section with a new data quality check method. Stay tuned. Now the next data quality check method what we are going to explore is has completeness. Okay, so it will again take column as input and it will basically create a constraint that asserts column completion. So what this particular has completeness does, let us try to understand with one example. So here let me basically show you the same data frame what we are using in our this particular example. So here we are having A, B, C, D, E, F column, and has completeness we can apply like this way. The rest part of the code is same like earlier, only difference is in our check object what we have basically created from the check class. There currently we are using the method has completeness and we need to pass the column name on which we want to perform this data quality check. Let's consider the column name is E. So earlier we have basically used is complete or are complete. It basically tried to validate whether the particular column is complete or not. That is, if there is any single null value in that particular column, is complete or are complete was failing, right? But has completeness check how much the column is complete. Okay, that is has complete basically allow a certain amount of null value also in that particular column. In this method you can basically control how much percentage of null value is tolerable. So when I am saying has completeness A, comma, lambda x colon x greater than equal to 0.8, that means I am basically trying to validate whether my A column is at least 80% complete or not. That is 20% null value is tolerable for this particular A column. And then we are applying run method and we are basically getting the result set as a data frame. So here A column if you see it is complete. That is 100% it is having non-null values. So obviously the non-null amount is greater than equal to 0.8, that condition is satisfied. So if we run this particular data validation check, it will be successful, right? Now let's observe the failure case as well. So df.show I'll apply, and here this is our data frame. Now let's consider on the C column we want to apply the has completeness validation, and the condition what we have given here, completeness for the C column should be greater than equal to 0.8. If this condition is satisfied, then only you pass this validation, otherwise fail. So now let's validate what is the completeness percentage for the C column. Okay, so here we are having our C column. The first row is complete, so I am writing 1. Second row is complete, I am writing 1. Third row is null, so I am writing 0. Fourth row is complete, so I am writing 1. So here if you total sum them up, 3 out of 4 rows are complete. That percentage or fractional value if you make, it will be 0.75. So for the C, the completeness amount is 0.75. But here we are putting that it should be greater than equal to 0.8. So obviously what will happen in this particular case, if we run this check, the validation will fail. So let's see. And here if you observe, the constant status is failure. Because for the C column, the completeness amount is 0.75, which is less than 0.8. Okay, right? I hope you are getting it. What is the difference between is complete and has completeness? That is complete basically try to check whether all the rows are not null or not. Okay, that is completeness value should be 1. But here in has completeness, you can control up to a certain limit. This much amount should be complete. That is, it basically allows certain number of null values also in the column. Okay, maybe you are having a particular business use case where in a particular data frame a column can have a limited number of null values. So in those cases, to validate this particular has completeness can help us. Okay, now here is a small task again for you. If I apply df.show, here we will be getting D column. Now you need to tell me here if I am applying this has completeness condition on D column greater than equal to 0.5, whether it will pass or fail. Pause the video, try to think about the answer. Here I am explaining. Okay, so let's see about D column. If we compute, so D column first value is non-null, so 1, second value is non-null, so 1, last two null, so 0. Okay, so 2 out of 4 rows, that means 0.5. So here what condition we have given? That for the D column, check whether the completeness is greater than equal to 0.5 or not. And for D column, we have calculated that the completeness is 0.5. So this condition is satisfied. So this will success. Okay. So here if I run this code, here you will see it is successful. Right. So I hope the concept of has completeness is also clear to you. In our next section, we are going to explore another data quality method related to PyDQ. Stay tuned. So let's try to understand our next data quality check method, and that is RNA complete. Okay, so what it does, it basically creates a constraint that asserts any combination in that combined set of columns whether they are complete or not. So there are two very important points. One is combination it is checking, and in a set of columns it is checking whether they are complete or not null or not. So what is that? How RNA complete works? Let us try to understand with this example. So we are having this data frame. Let us consider a set on which we want to apply RNA complete quality check, and that columns are A and D. So how RNA complete works? So as a first default step, we need to create a check object from our check class, and then we will call this particular method using check.RNA complete, and there we need to pass the list of columns. And how RNA complete will check? So it will basically check whether A is not null or D is not null. Okay, if any of this is not null, it will return output as 1. That is basically it is correct data. And if both of these data, or in your list maybe suppose there are n number of columns are provided for any particular row, if for that all columns if the values are null, then only RNA complete will return 0, and as a result our data quality check will fail. Okay, right? So in simple words you can remember like this way, like when we were using R complete, what were happening? It was basically checking A and the other column, A and multiple columns. Let's consider we are putting D. That time A should be not null as well as D should be non-null for all the cases, for all the rows within that data frame. But in this case what it does, RNA complete basically check whether any one column value for the list of columns whether they are not null or not. If any one among all of them is not null, then it will be correct, or else if all are not null, then it will return 0, and as a result for that particular row RNA complete will fail the quality check. Okay, so let us see in this case what is happening. So let's consider A and D column. So first one not null, this is also not null, because both are not null, RNA complete will return 1. Then A is not null, D is not null, it will return 1. Then A is not null and D is null, because at least one is not null in that list, so still it will be 1. And here A is not null and D is null, because at least one is not null, so it will be 1. So here out of all the rows for A comma D, this column combination, for all of them we are getting value 1. That means in this combination for all the rows in our data frame there is at least one side where we are getting not null values, right? So here RNA complete check will pass. So let's see the implementation now. So here if you see, I have written that same code. First this part is same like earlier, and here we are creating our verification suite, and here we are calling that RAnyComplete method using the check object what we have created here from the check class, and here we are passing a comma d. Okay, and as we discussed, because for all the elements a is not null, so this particular check will be success. Okay, and if you check the explanation, you will be able to understand easily. Like here a is not null or d is not null. If you put here one more column, it will check a is not null or d is not null, or that column what you are putting here, that is not null. So if any one particular column value among this complete list is not null, then it will be satisfying the data quality check. Okay, so the difference between RAnyComplete and RComplete is, in case of RComplete we were putting AND condition here. That's why if any one among that list is becoming null value, the complete check was failing. But here OR condition we are applying in case of RAnyComplete. That's the major difference. Okay, right? Now let's implement for other columns also. So this is our data set. Now C and D, on these two columns if we apply RAnyComplete, what will happen? Let us try to understand first. Okay, so here if you see C column not null, D column not null, so obviously it will be 1. C column not null, D column not null, it will be 1. And here C is null, D is also null. Okay, so here in our this particular list whatever we are putting there, this particular condition is appearing that in a particular row both elements are null. So that time RAnyComplete will return 0 because not a single element is not null. And here for this particular row, here it is 1 because C is not null. So here all the rows are not becoming 1. So here data quality check will fail. Okay, so let's see. So here I will run this code, and here you will see that it is failed. And why it is failed? Because there is a particular place where this condition is not getting satisfied, like C is null as well as D is null. That is basically this particular place, right? And let's see one more case, maybe here C comma E, that is C column and E column. So what will happen in this case? Let's try to derive. So here C is not null, E is null, does not matter because at least one is not null, so output will be 1. C is not null, E is not null, it will be 1. C is null, E is not null, so here also 1. C is not null, E is null, so here also 1, because at least one in one of the side is not null. So here all are 1, so RAnyComplete condition will be satisfied, right? So let's see. If I run this particular cell, here you will see that it is success. Okay, right? So I hope you are getting it, how RAnyComplete works. Obviously you can apply multiple columns also, like for example here C, D, and if I pass A also as a column, and because in our data frame all the elements in A column are having data, none of them are null, so as a result RAnyComplete will success. So earlier it was failing, but because of this addition of A column, here it will be passing. Okay, and as I told you, see the condition how it got changed. It is now checking C is not null, or D is not null, or A is not null. If any among all this complete list is not null, then RAnyComplete will give success status. Okay, right? So I hope you understood the importance of RAnyComplete. So this is all for this particular section. We will catch up in our next data quality check section. The next data quality check method what we are going to explore is unique. And from the name itself, I hope you can understand what it does. Basically, it helps in duplicate validation in a column. It creates a constant that asserts on a column uniqueness. Okay, that is, suppose one particular column in your data frame should be always unique, and you want to validate that using PyDQ, then you can utilize isUnique method. Okay, let me quickly show you with one example. Suppose this is our data frame, and I want to check A column is unique or not. That is, there should not be any duplicate element available in this A column. So for that, to write the code, this is the way, which is pretty much same like earlier, like this part is same, only in the check result, in the verification suite, when we are calling .add check, there we need to put like this way, check dot is unique is the method, and it take the particular column name on which you want to apply uniqueness, and then we are applying .run to run the uniqueness check on this column. Okay, and then we are reading the outcome as a Spark data frame. So let me run it. Obviously it will success because A column is having no duplicate value. So let's see. And here you can see that it is successful. right? Which is obvious. Now let's observe one failure case as well. So here you can see that this is our data set, again same one what we discussed earlier, and let's consider B column. Okay, if you see in B column there is these three and these three, so there are duplicate elements available, right? So if I run is uniqueness on the B column, it will be failing. So let's observe. So here you can see that it is basically failed, and the message what it is showing that 0.5 does not meet the constant requirement. Okay, and how this 0.5 value is coming, that is pretty obvious, like what we discussed earlier. 2 rows out of total 4 rows are unique, rests are duplicate, right? So 2 divided by 4 is 0.5, so that's why 0.5 value is coming. Okay, let's test it for one more row. Suppose I am applying df.show, and this time if I want to apply on D column, so here if you see that D column has null values also. So when we apply is unique, it excludes the null values, and apart from that whatever is there on that it try to apply uniqueness. So if I apply uniqueness on D column, 10 and 4 are the key elements which are not duplicate. So if I apply is uniqueness on D column, it will be getting success. So if I run this code, here you can see it is successful, right? So in this way we can validate whether a particular column in our data frame is satisfying uniqueness criteria or not. We will catch up in the next section with our next data quality check method. Stay tuned. So the next data quality check method what we are going to cover is has uniqueness. So it is similar to has completeness. Like is complete basically check whether 100% elements within a particular column is complete or not. That is, there should not be a single non-null value. But has completeness was allowing us to check completeness for a particular column is greater than a certain fraction or not, or less than certain fraction or not, or equal to certain fraction or not. So basically we can put a condition, it might not be necessarily 100% completeness, right? Same goes for the difference between has uniqueness and is unique. Is unique basically check whether all the elements within a particular column are unique or different or not, right? But has uniqueness allow a certain amount of repetition in a particular column. You can check whether a particular column is having uniqueness greater than a certain fraction value, or less than a certain fraction value, or greater than equal to, or less than equal to, or equal to a certain fraction value. This kind of condition you can apply in your data quality check for uniqueness. So let me quickly show you with one example. So if I apply df.show, here we are having our same data set. Now if you check a column, it is 100% unique, right? So if you want to apply has uniqueness, it goes like this way. First element should be a list, okay? And here on the A column we want to check the uniqueness, and we are expecting that A column's uniqueness should be greater than 0.75, right? That is 25% or 0.25 fraction amount of our A column can be repetitive. Still there will be this particular check passing. Okay, so in another way we can say, if in our A column the amount of repetition or non-uniqueness or duplicacy is less than 0.25 or less than 25%, still our this data quality check will be passing. Okay, right? So here if I run, obviously what I will be getting is success. So let's run it, and here you can see it is success. Okay, so it is checking uniqueness on the A column. Now let's see a failure case as well. So df.show, if I apply, this is our data. B column has uniqueness, we already calculated 0.5, right? Because 2 elements out of 4 rows are unique, rest are duplicate. So B column's uniqueness value is 0.5. Now if I apply has uniqueness like this way, that whether B column's uniqueness should be greater than 0.75 in a particular data quality check, and if we run, then in this case this will be fail. Okay, because B column is not following this condition, which is having uniqueness 0.5, which is less than 0.7, right? You can apply greater than, equal to, less than, equal to all possible comparison operation. And here it is clearly showing the failure reason as well, that value 0.5 does not meet the constant, right? So I hope has uniqueness is also clear to you. Each time I am basically showing you only one particular data quality check method in a particular example. Obviously, as we discussed in very beginning, you can put n number of data quality checks together, and when you will run that particular code, it will validate all those checks against our data frame on a particular column, whatever you are mentioning, or in the list of columns what we are mentioning, and then it will give the summary, right? But here, just for simple understanding purpose, I am explaining the examples with only one data quality check, right? I hope you are getting it. Now in our next video, we will be discussing another data quality check method. Stay tuned. Next data quality check is pretty straightforward, and from the name itself, intuitively we can understand what it is doing, that is has been. It basically helps us in validating a condition that whether for a particular column the minimum value is greater than equal to this, or less than equal to this, or equal to this, like that. Okay, so let me show you quickly one example. df.show, if I do here, this is our data, and maybe for example on the B column, data quality check can be, as per business logic, the B column's minimum value should be 2. Okay, in that case you can write the data quality check code like this way, that check.hasBeen B column, and that minimum value should be 2. But here this will be failing, because here in our data in the B column we are having minimum value of 1, right? So let's run it. And here you can see that value 1 does not meet the constant requirement, because minimum value first it calculated, which is 1, which is not satisfying our condition, so that's why it failed. Okay, so if I just put less than equal to 2, this kind of condition, then it will be passing, because the minimum value is 1, which is satisfying this condition, and we are getting success, right? So this way has been work. Following that same pattern, we are having has max, which help us in applying a data quality check on a maximum value for a particular column. Has been helps us in applying a constraint or data quality check on the mean value of a column. Has sum basically helps us in applying data quality check on the sum value for a particular column. For example, a column is having probability distribution. That value should not exceed 1, because sum of probability should be 1, right? In those kind of cases, for data quality check, you can apply has sum. So let me show you quickly all this. So if I apply df.show, this is the data, and here I am applying 4 conditions together just to show you: has mean, has max, has mean, that is average, and has sum. Okay, so let's try to understand manually first whether conditions will be satisfied or not. So has mean, okay, B value minimum value should be 1. For the B column, minimum value is 1, so this particular condition will be satisfied. Then has max, C column should be 9. So for the C column, the maximum value is here 8, but here we are checking a condition for 9, so this condition will be failing. For the D column, the average value should be 2. For the D column, if you check average value, what will be the average? 10 plus 4, 14. 14 divided by 2, it is 7. Obviously, while calculating average, we should not consider the null values in the column, right? So the average is coming out 7, so it is not equal to 2, so it will be failing. And for the B column, the sum value should be 9. So if you see 3 plus 3, 6, plus 2 plus 1, that is 8 plus 1, 9. So this will be passing, okay, because P values total sum is 9. So this will be passing, these two will be failing, and this will be passing, right? So like this pattern, you can apply multiple conditions, and if I run this code, here you will see that for the B column, the minimum value already we discussed that it is successful, and for the C column maximum value it is 9, but that is not true. C column is having maximum value equal to 8, so the C column constraint failed, and it is clearly showing value 8 does not meet the constraint requirement, right? Mean constraint, mean value of the D column we calculated 7, and 7 is not equal to 2, so this constraint also failed, and the sum of B column is successful because it is 9, because 3 plus 3 plus 2 plus 1 equal to 9, right? So this way you can do this kind of basic statistics check, right? And then the next data quality check method is non-negative and is positive. From the name itself, again, I hope you can clearly understand. Non-negative basically helps us in checking whether for a particular column the values are greater than equal to 0 or not. That is, no value in that column should be less than 0 or negative value. But is positive, what it checks? It checks whether all the values in that particular column is greater than 0 or not. So basically, if in a particular column some value is 0, still the non-negative may pass if all other values are greater than equal to 0. Okay, but positive will fail if there is 0 value in a particular column. So it is just like, is non-negative greater than equal to 0, is positive greater than 0. As simple as that, what we apply in mathematics as well. So here we are having a data frame df1, and here we are having A and B column. So if you see for A column, all values are greater than equal to 0. So non-negative will be passing for A column, but it will be failing for is positive condition, because for is positive all values should be greater than 0, but here we are having an element which is equal to 0, right? So is positive will be failing, and for the B column both non-negative and is positive will be failing, because here we are having negative values, right? So that check we have applied here: is positive A, is non-negative A, is positive B, is non-negative B. So here both of these B related things will be failing because B has negative values, and for A the non-negative will be passing but positive will be failing because A column has 0 value. So here if you check, only one is successful, and that is A column non-negativeness. A column positiveness failed because here if you scroll right, value 0.75 does not meet the constant requirement, and it is coming 0.5 because this value, this value, this value, 3 values out of 4 are satisfying the condition. 3 divided by 4 is 0.75. That's what it is shown here, right? And for the B column, because it is having negative values, so both is non-negative and is positive failed, and that's what it is showing here, right? So I hope you understood this. Now the next data quality check what we are going to discuss is contained in. It asserts every non-null value in the column is contained in a set of predefined values or not. Okay, so when it helps, suppose you are having a categorical column or string column, and that can take only specific string values only in that particular business context. Okay, now if there is some other string value coming, that means that is wrong value or wrong data. So we might need to go to the source team and ask that how this string value came, either resolve it in the source itself, or we might need to add that extra new string in the data quality check, right? So that kind of validation if you want to do, you can use is contained in. Okay, so here is an example, like A column is a string column. For that A column, suppose the possible values what it can take as per business logic is foo, bar and bus. Okay, so if you want to check whether A column's values are only falling under this or not, it should not take any other string value. So in those kind of cases, you can apply check.is contained in. So first argument should be column name, second argument should be the list, what all possible values it can take. Okay, now here this check will be obviously failing because in the A column we are having CAB, which is not available in that list, right? So if I run this particular data quality check, and here if I scroll right, here you will see that it failed, right? And let me show you success case also. So here I will run it, and here now I have added cab also in this particular list, and that's why here you will see that this time it got successful, right? So basically it is like in clause data validation what we do in SQL. I hope you got it. And point to be noted, is contained in can check like this kind of values only for string column. Okay, so you can always get this kind of information from the documentation. Just you can search with is contained in, and here you can see that it asserts every non-null value in a column contained in a specific set of predefined values or not. Column should be string column. The allowed values what we are putting as a list, that should be also string. Okay, right? And also point to be noted that while doing this particular in clause comparison, if in that string column there is some null value, it will be ignoring. Okay, so that also I can show you with one simple example. So here I can maybe write df2 equal to, I'll just add a dummy column here where A will have null value, and yeah, df2 dot show I can apply, and then maybe let me copy this particular code and paste that here. So this time if you see in the A column, apart from foo, bar, bus, cab, we are having null values as well, but here we are only putting these conditions. Okay, but is contained in is intelligent enough to ignore this null, and it will only compare between the rest of elements. Okay, so if I run, still it will be successful. If I scroll right, here you can see this success, right? So I hope the importance of is contained in also clear to you. It basically checks whether a string column values are fallen under specific predefined set of strings based on that business requirement or not. So this is all for our this section. We will catch up in the next section. So our next data quality check method what we are going to explore is contents URL. And from the name itself, I hope you are getting it. What it does, basically it helps in verifying whether in a particular cell, in a particular column, URL is available or not. Okay, so let us see with one example. So here I am creating a data frame where we are having a column called description, within which for some cells we are having URLs available, right? So if you observe this particular data frame, as you can see in row number 2 and row number 4 for the description column, here we are having URLs available. Now suppose as per business logic, in all the cells within this particular column, the URL should be available. That kind of check if you want to implement, that time you can opt for contents URL. And this is the way how we can write the code, that rest part is same, just check dot contents URL and the column name we need to provide. Okay, so here column name is description. Suppose the value what we are expecting is in all the rows for the description column, the URL should be available within that particular text. That time we can put this kind of condition that x equal to 1. So using this particular data quality check, we can validate whether in all the cells the URL is available or not. And if for any one single cell it is not available, this data quality check will fail. So I can run this one. And here you can see it failed. And value 0.4 does not meet the constant requirement. How this 0.4 is coming? Because here you can see 1, 2, 3, 4, 5. Totally we are having 5 rows. Out of that, only for 2 rows we are having URL available. So 2 divided by 5, it is 0.4. And this value we are validating against this lambda expression. So 4 not equal to 1. So that's why this check is failing. Now suppose I am changing this particular condition like x greater than equal to 0.3. Right? That is in at least 30% rows, the URL should be available in the description column, then only this data quality check will pass. But in our case, already we have calculated that in 40% rows it is available, so this data quality check will be successful. Okay, so contents URL basically helps us in checking whether within a particular string the URL kind of substrings are available or not, right? So here we are getting success. I hope you are easily getting this. Now, same like that way, contents email also available, which helps us within a particular string column whether we are having email address or not. For that, here I have created one data frame, and here you can see that in 3 rows out of total 4 rows we are having email address available. Now let's apply contents email on this particular column, check for email, and here we are validating whether in at least 30% rows the email address available or not within this check for email column, right? But here 3 divided by 4, that is in 75% rows we are having email address available. So obviously, clearly this particular check will be passing. Okay, right? Now let's run for one failure case also. df4.show this one, and here now I have given a condition which will fail. That is, the email address should be available in maximum 10% rows within this particular column. Okay, that is the number of rows for which email address will be available in this column should be less than equal to 0.1 or should be less than equal to 10%. But in this case, we have already calculated the number of rows for which email address is available, that is 75%. So obviously this check if we run, it will be failed. So if I run this, and here you can see this failed, the value 0.75, that is 75% does not meet the constant criteria, that 0.75 less than equal to 0.1, that condition is not satisfied, for which it failed. Like this way, we can easily validate whether in a particular string column the email address available or not using contents email, whether URL available or not using contents URL, what we discussed here, right? So this is all for our this particular section. We will catch up in our next section with some new data quality checks. So our next data quality check method is hash pattern. And I hope from the name itself you are getting it. It will help us in matching one predefined pattern within a particular column. Okay, so the arguments whatever it take is column name, then pattern, that can be a regular expression, then the lambda expression or assertion that within this particular column this predefined pattern should be followed this much fraction or this much percentage, that we can configure in the assertion. Okay, so let's try to understand this with one example. Suppose here we are having our data frame, and as per business requirement, this A column, it should start with BA, and after that whatever R or Z, any one particular letter can come, and like this particular pattern should be followed at least in half of the data set. So that time how to write the code? This is what we have written here, verification suite on data df. So on this data frame we'll be applying this check, and check dot has pattern. So as a first step we need to provide the column name. Then here, as we discussed earlier, assertion clause x colon x greater than equal to 0.5. So this is our assertion clause which will check the pattern is followed in at least half of the dataset available in a column or not. Now we need to provide the pattern. So to put the pattern, here I am giving a comma. Then here we need to write the raw string for the regular expression. So R, which stands for raw string. The value should start with BA, and after that R or Z, any one particular letter can come. So this is how we generally write the regular expression, right? Now let's run this one. Obviously it will be succeeding because here out of 4 rows, in 2 rows we are having this particular pattern followed. So hopefully this will pass. Let's see. So here we can see it is successful, right? Which is pretty obvious. Now let's try with another pattern. So let's consider the business requirement is the value in the A column should start with F, and then there can be anything. So F start. Okay. And this particular pattern should be followed in at least 50% in our data set. Okay. So x colon x greater than equal to 0.5. Okay, right? So this is our regular expression pattern. But here we can see in our dataset only in the foo this pattern is followed. Rest nothing is starting with F. So here actually 1 out of 4, that is only 25% or 0.25 fraction of our dataset is following this particular pattern. So as 0.25 is less than 0.5, so our assertion will fail and our data quality check will fail. Okay, and here we can see constant status is failure, value 0.25 does not meet the constant requirement. Okay, right? So this is how you can put some regular expression to validate the data against a particular column. And this is how you can perform data quality check for pattern matching using .has pattern. I hope you understood this. This is all for our this section. We will catch up in the next one. Stay tuned. The next data quality check method what we are going to explore is greater than. So it will take 2 columns as input and it will validate whether in each row the value of column A is greater than value of column B or not. So let us try to understand with a very simple example. So here I am having a data frame and let's focus on the B column and the F column. So here if you see for each row the B column value is less than F column value, right? Now, if this kind of validation we need to do, that whether in a particular data frame, one particular column value is always greater than another particular column value. For example, in a data frame, we are having different employees CTC breakdown, then the CTC column will always be higher than the basic salary of that employee, right? It is not possible that basic salary is greater than the CTC. So for this kind of validation, this is greater or is lesser will be helpful. So is greater than, as I told you, it will always validate whether the first column what we are putting is greater than the second column value or not for each. So here if you see for the F column, all the values are higher than the B column. So if we run this particular test case, it is successful. Correct? I hope you are getting this. And now let's consider what will happen if we are having null values in that column. For example, the C column and B column, if we try to compare. So here I will write C and then B. So if you see for the first row, C value is greater than B. Second row also C value is greater than B. Third row is not comparable, right? Because C is null. So null I cannot compare with 3. Null is greater than 3 or less than 3, we cannot say, right? So for this particular null value, this comparison will fail because for all the rows, C is not greater than B. That cannot be determined, right? So that's why we are getting failure status. Following that same pattern, we are having less than, is less than equal to, is greater than equal to. These all 4 will follow that same pattern. Just now what I have shown you the demo for is greater than. You can try to do some experiment around these 4. You will get similar result. From the name itself, I hope you are getting it what it does, like is less than. So it will basically check whether for all the rows the column A value is lesser than column B value or not. Is less than equal to will check whether for all the rows column A value less than equal to column B value or not. Is greater than already we discussed, and is greater than equal to will check whether for all the rows column A value greater than equal to column B or not. Is greater than only check whether column A value is greater than column B or not, and if we are putting greater than equal to, then obviously from the name itself we can understand it will check greater than equal to condition, right? So I hope this particular 4th set of checks easily understandable with this single example only. We will catch up in our next section with some other data quality check. So the next data quality check method what we are going to discuss is has data type. So this basically helps in checking whether a particular column is having a specific data type or not. So let us try to understand with one example. So here let's consider we are having a data frame, and as here clearly you can understand that a column is string data type, right? Now suppose as per business logic, ideally this a column should be having string data only. So that time how we can check? Here you can pass the column name, then comma, and here let's check the documentation. Okay, so has data type, first is column, the second it takes is data type, and only some predefined data type we can check. So you can click on here, and these are the certain set of data types what the PyDQ currently support, like boolean for true false case, fractional for any decimal number, integer for integer values, null for checking nulls, numeric for checking integer as well as fraction, and string for checking any string data. So in our case it will be basically string, right? So here I can give this one constrainable data types dot string. Okay, right? And obviously as per our manual inspection this check will be success because a column is having all the string data type. Now let's check the constraint for another column, B column let's consider. Okay, but here if you see B column is having integer data. So if I now run this constrainable data type dot string, here ideally it should fail, right? And here it is failing because all the column values are integer data type, but here we are checking against string, right? So for B column to satisfy it, we need to convert this string to integral. Okay, and then if we run, here we will be getting success, right? Then another column, maybe for C column, let's see. C column has null value, so let's see how it will react to the null values. So ideally C columns, all other data as we can understand it is integer data type, but one has null value. So let's see, and here you can see it is still success. Okay, that means null value it will ignore while checking this data type format, right? Then maybe one more data type we can verify, that is null. Okay, so null data type will verify whether in a particular column the data type is of null category or not. But if you consider the C column, only one element is null out of 4 rows. So only 25% or 0.25 fraction is satisfying this particular criteria. Rest are not satisfying, rest are integer. So obviously this check will be failed. So if I scroll below, here you can see it failed, and it is clearly showing the message 0.25 does not meet the constant requirement, right? So this is how using has data type you can validate the data type for your data frames, and these are the supported data types as of now. I hope you understood this. With this particular data quality check, all major data quality checks whatever currently PyDQ supported, I have covered almost everything. Rest there are few like approximate, quantile, and then mutual information entropy. This we generally use very less in our data pipelines, so whenever required we can explore in future. But in our next section we will be focusing on how we can implement this particular data quality check using PyDQ in various AWS services, how to do it in AWS Glue or Lambda or EMR, etc, etc. These things we'll be exploring in our successive sections, so stay tuned. So now let's try to implement these data quality checks in AWS systems. And because we are using PySpark, so the first AWS service where we are going to implement this data quality check is AWS Glue, right? Because that is having default Spark support. So here I will search for Glue and I will open in a new tab. Okay, now to run PyDQ in AWS Glue we need two things. If I scroll completely up here, you will be able to see that we installed PyDQ. So this one we need to provide as additional Python modules, okay, because this particular Python module will not be available by default in our Glue execution environment. And apart from that, here if you see, when we created this Spark session, then there are some jars which it basically installed in the runtime, because we are using jars.packages. So from the Maven repository it was directly downloading in the runtime. But when you are working with AWS Glue, this particular direct download is not possible. We have to basically download that particular jar from Maven and keep it stored in some S3 location, and we need to provide that particular extra jar path in AWS Glue job. Then only it will able to access that. Okay, so this package installation and Python module installation we need to perform. So for that, here I will be going to Maven repository. The link I'll be providing in the description box, from where you can easily download the jar. So here you can see this PyDQ jar I am downloading. Okay, and here I have created a S3 bucket where I have created a dependent jars folder. So there I will be uploading this jar. So upload, add files, I'll go to download section, and here I'll be choosing the jar file. Okay, and here I'll click on upload. So this step is done, and here if you go here, you will get the complete jar file path. I'll go to Glue jobs, ETL jobs, and then here script editor, and here I want to write a Spark job and start fresh. So create this script. So this is a script, later we will update. As of now, let us go to the job details and scroll below. So here you will be getting an option of dependent jar paths. So here we need to provide this PyDQ Spark jar file absolute path what we have uploaded in S3, right? And now we need to also mention the pip installation for PyDQ, because that PyDQ Python module is not available by default in our Glue execution environment. Okay, so here if you check, this is our PyDQ latest release. If you click on release history, so these are different releases available for our PyDQ. So last it was published long time ago, 2021, and then since 2023 it got published multiple times. So don't use the old versions from 2021, because those are not working in a very good manner with Glue that I have tested. So I'll try to install something which is launched recently, like 2023. Okay, so here I will choose PyDQ, and here job parameter I will add. So PyDQ equal to maybe the version what I want to install is 1.1.0. okay, 1.1.0, right? And the key what we need to provide is additional Python module, so that I will be writing here. So here I'll add that. Okay, so with this way automatically when Glue job will be running, first this particular Python module will be installed, then only our Glue job will be executed, right? So that's pretty much it. And apart from that, here we can give the script name better, like data quality AWS Glue. Okay, the IAM role we can choose, maybe service role I can opt for it. Okay, and then supported Spark version, either you can choose 3.3 or 3.1. So as of now I'm choosing 3.1 for experimentation purpose, and I will click on save. Okay, right? So here the job is getting updated. Till then, let us explore our Python code. So here we are doing import OS, and as I told you, if you are using PyDQ, we need to configure Spark version. So because we are using Spark 3.1 in the Glue, so I have written here 3.1. Okay, then here we are importing everything related to PyDQ. We are importing Spark session and all the SQL functions, importing Boto3 if it is needed, and then here we are creating the Spark from Spark session, and then input path. So here you can provide some S3 path where some CSV file will be available, for which we want to perform some data quality check. Okay, so that path I'll be providing. So here we are reading that particular data set. Here I am printing this schema. This is totally optional. And then here I am basically creating the check object for the check class. Okay, the name or the description what I am giving is Glue PyTest. And then here I have written certain checks. Okay, so let me show you the data set, so that way we can understand in a better way what all checks we have written. And here if you see, this is a very popular IDs data set. So in this particular data set, whatever checks we have implemented are like this. So first one is unique ID. So the ID column, if you see, it is basically indicating kind of a monotonically increasing number. So this should be unique as per our business logic that we want to validate. Then class name should be complete. Like it should not happen that class name is having null value, right? Because as we know that IDs dataset we use for training. So at least for training dataset, the class should be known. So it should not be empty. That check we are applying. Then petal length non-negative. So petal length is a length feature for a flower. It cannot be negative value, right? So is non-negative petal length we are checking, and is contained in the class name can take only these two value, IDs Virginica and IDs Setusa. Because that's how in our dataset it is having IDs Virginica, and here we are having IDs Setusa in the lower part. As we know, these are two categories of IDs flower, right? So these all checks we are applying on our dataset. I hope you are getting it. And then we are calling .run to apply that on our dataset, and then we are reading that particular result set in a Spark data frame, and we are printing that data frame also. Now this particular data frame, whatever we got as part of result of our data validation, that we are writing in some S3 location. Okay, so it is a different S3 location with validation output as folder name. Okay, and then we are doing a simple check, that is if there is any row which is having constant status equal to failure, that means some of our data quality check has been failed, right? So that particular failed records we are first trying to find out, and if this particular filter dataset count value is greater than 0, then we are calling it as fail else pass. Okay, so this is just to print that it is failed or passed. Maybe you can send Slack alert or email notification that data quality check failed for this particular dataset, right? And then maybe data engineers can inspect what is the issue, where it failed, etc. So this is a simple code. So I'll just copy from beginning, and then here I'll go to script, and here I'll paste it. Okay, the only change what we have to make is input path. So here I have already created a input file S3 directory. There I'll be uploading this set1.proper CSV file. So I'll click on upload. So here the file is uploaded. I'll open in a new tab. So this is the S3 URL. I'll go to the script and I'll paste in the input path. Okay, right? So this particular file, it will validate, it will perform all these data quality checks, whether ID column is unique or not, whether class name is having any null value or not, whether petal length is having negative value or not, and whether class name is taking only value between these two or not. And after doing all this data quality check, whatever results it will be getting, that we are going to store in this location, that is validation output. That is basically, let me show you. This particular place. Okay, currently it is empty, right? So we'll see what is happening. So I'll save this particular glue job, and here our job is updated successfully. I'll just click on run. Okay, so here we can see the status, it is currently running. So let it run. So ideally what should happen, first it should do a pip install PyDQ module, and it should take the jar also from the jar file location, and then it should read the data from S3, apply the data quality check, and the check result set, whatever earlier we were getting here in our Google Colab notebook, like these kind of things, this it will write as a CSV file in this validation output location. Okay, so you'll see that. Let's wait for some time till the job is running. So here the job failed, and here it is showing check object has not attribute is unique. Okay, sorry, here I have given a T, so I'll just update that. Here it should be UNIQUE. Okay, sorry for this spelling mistake. I'll save this and run it again. So here I'll go to run section. So till now, if you see, our validation output is empty. Let's wait for this job to complete. So here our glue job is successful. So let's go to our validation output location. If I refresh, here you can see currently it is 2:30 AM. Just at 2:29 AM 34 seconds, the file got landed. So let's download this file and let's see how the data quality checks happened. So in downloads, and then here this is the file. I'll open it in Notepad++. So the first check what we have applied on uniqueness on the ID column, it is successful. Completeness for the class name, it is successful, and class name should only contain ID status ID is Virginica, that is also successful, and petal length value should be greater than equal to 0, that is also successful. We have given the conditions such that it will success, right? Now let's see a corrupted file, and that is like this. Here if you see, this dataset is having some problem. For example, petal length or sepal length, sepal width, petal width, anything cannot be negative. As I told you, this is feature of a flower, it is a length, right? So here if you see in the second row excluding header, here in the petal length we are having negative value. So that means this is a wrong data is flowing from the source. So our data quality job should able to detect that, and it should give us an alert, right? And also in the last I have done intentionally one more change, that is ID column is not unique. Okay, last column ID I have made it duplicate, right? So we'll observe whether our PyDQ framework able to detect these issues or not. So in the input file, I'll upload this corrupted data and I'll copy its S3 location. I'll go to the scripts and here in the input path, I'll be updating it. Okay, that's all. No other changes. I'll save this and here I will run it. Okay, so currently here you can see only one file is available. Soon one more file should be available due to the second run. And here when I'm writing the data, that time I am writing in append manner, so the data will not be overwritten, a new file will be created. Okay, so that will inspect. So let's go to the run section. Currently our job is in running state. Obviously if you want to check the logs in real time, you can click on continuous logs. So here the logs will be coming in real time as our Glue job will run. Okay, so here our job is successful. So let's go to our S3 location in the validation output. I'll refresh and here you can see another file at 2:34 AM got created just now. Okay, so let's download this particular file and we'll inspect whether our data quality check failed or not. So I'll open this and here you can see the class name column we were checking complete or not, so that was complete in this file also, so successful. Petal length value should be greater than equal to 0, that is not negative. That check we have applied, but that is failed, and the reason is we have intentionally added a negative value in the petal length. That's why it is showing that 0.99 fraction or 99% matching, but 1% value or 0.1 fraction value is not matching. Okay, right, does not meet the constant requirement. Then here class name should contain values between only IDs Virginica, ID Setosa, that is successful. And on the ID column we applied uniqueness, but we have intentionally kept duplicate ID. So here you can see that this particular check also failed, right? This value does not meet the constant requirement. So this is how we can run PyDQ based data quality validation checks on our dataset in AWS Glue. All we need to do is configure the jar file and the pip install for PyDQ properly in the Glue job in this manner. Okay, and then we can keep our simple Spark code as we discussed in Google Colab notebook. So this is all for our this section. We will catch up in our next section with some new concepts. Stay tuned. So apart from using PyDQ for data quality validation in AWS Glue, Glue is having its own data quality check transformation as well. So let me show you that also when discussing data validation in AWS Glue. And for that, what you need to do, go to ETL jobs. You can click on visual ETL, and here maybe we can read the data from some S3 location. And this is our source, right? In our previous section, we have read the data from basically this particular location, set2_proper.csv. Here we are having that data. So here in this S3 URL, I'll be putting that. Okay. Data format. So here in this case, it is a CSV file. Comma delimited, that is fine. And first line contains the column header, that also fine. So we can check that. And infer schema, if you want, you can make this enabled. Okay, right? And then here what we can do, here if you search for evaluate, then here you will be getting a transformation evaluate data quality. So this is basically built on top of Amazon DQ only. So if you see this transformation, whatever it supports, you will find a lot of similarity with what we already discussed earlier. So let me show you that. So here from S3 we are reading the data first and then we are passing that data via evaluate data quality. And here you can put all the different data quality checks, like column count should be this much, whether this column exists or not, column length condition you can put. If you expand any of this, you will be getting the sample example as well. Like for example, in your S3 data, suppose we are having a column called column A, that column length should be less than 4. If you want to do this kind of validation, you need to put the code like this way. So like this way, multiple checks are there. So let's try to replicate that same what we did in our previous section. That is, first we were checking that whether ID column is unique or not, right? So we can search for unique, okay? And here you will be getting an option of easy mode. And the code will be automatically getting created, just you have to click the plus icon within this rules section, that is within these square brackets, and you have to click on plus. Okay, so we want to check whether our ID column is unique or not, like in our previous section we have done. Then class name should be complete, that is there should not be any null value, right? So for that we can search for complete and we'll be getting the completeness option. So give a comma here and then click on completeness. Okay, so if you want to check we don't want to check completeness, we want to check is complete and the column name is class name, whether class name is complete or not, right? Then the next check what we want to do, the petal length should be non-negative, right? So I can basically remove that one, and if I scroll below you'll be getting a transformation called column value, right? So I can click on that and it is giving some example like column value in our case petal length, and here you can put any condition kind of thing. So if you want to put a simple condition, petal length should be greater than 0. Okay, right? Then the next transformation what we want to apply is class name should be within iris virginica and iris sedosa. So the same transformation column values we can apply again, and here if you see that some example is also provided, column values a in 1, 2 like that. Okay, so we can apply this kind of code. So it is a very simple thing, kind of drag and drop. So column values of class name in, and we can put this condition that we should be within iris virginica or iris sedosa. Okay, right? So with this we have replicated our PyDQ code. We can scroll below and you will be getting an option that what output you want to get. So obviously original data we want to get as output, and if for any particular row any data quality condition is not satisfied, that also I want to get as a separate column for that row. Okay, so you have to enable this particular toggle that add new columns to indicate data quality errors. Okay, and as soon as you will enable that, you will be getting one more row level outcomes added in this visual ETL. Now as the last step what we need to do, we need to write the data back to S3. So I can search for S3 destination, that is target one, and what I can do from this particular layer, let's put this input in this layer, so that way it will be standardized, and our target location in our earlier code, it was this particular section. So I'll be copying that and I can put this S3 target destination. Okay, so with this way our visual ETL transformation is ready, which will help us in validating the data from a particular S3 location, that is from this input file, and it will write the data in output location. Only the difference with respect to PyDQ is in PyDQ we cannot understand for which row which data quality check failed, but for in this case we can easily understand that due to this row level outcome. Okay, right? And then you can go to the job details section and I can give demo YT glue df. Okay, IAM role we can choose one existing one, right? And keeping all other properties as default, we can go to the script section now. Okay, now in visual ETL whatever we develop, automatically the script gets generated in the backend. So as a first step what we are doing, we are generating the data from one S3 location, then we are applying data quality validations like is unique, ID column, the class name should be complete, petal length value should be greater than 0, and class name should be in iris virginica and iris sedosa. Then we are applying that on our data frame, and then we are writing the data in S3 location. Okay, now once you get this particular code, you can obviously change it based on your requirement. Like here I can click on edit script, but remember if you edit this script, you cannot go back to the visual ETL to change the pipeline using just drag and drop option. So first implement all the changes in visual ETL whatever you need, and then you can edit this script to make it customized with respect to your own requirement. So I can click on confirm, and then here what I can do, that we are reading the data from S3 location, right? So maybe I can read the data like how we read earlier in our previous video, that is this way. Okay, I own it this particular section. Okay, so here we are reading the data from set2 underscore proper.csv, and here is our data set. Now to apply the next steps, what we need to do, we need to convert this Spark data frame to AWS Glue dynamic data frame. Okay, and that dynamic data frame we need to import and then convert this Spark data frame to dynamic one. So maybe I can take help of ChatGPT. So I can ask the question, write the code to convert Spark df to AWS Glue dynamic Glue. Okay, and it will be giving me the code. So as a first step, we need to import this one. So I'll be doing that parallelly. And then here, this is the code to convert Spark data frame to Glue data frame, and there is dynamic data frame dot from df, and here we need to pass the Spark data frame name, which is in this case data set. Okay, in Glue context we are passing this particular field is optional, we can delete that. Now we are having the dynamic Glue data frame, and that we need to apply in the next step. So we were having this Amazon S3 node 1, which we deleted basically. So I will replace with dynamic data frame, which we basically created by reading the data from S3 in Spark df, and then we convert it to dynamic. Okay, right? And then we are writing the data. That write operation also you can do in normal Spark way. Maybe you need to do some transformation where you are comfortable more with PySpark instead of Glue dynamic data frame. So you can delete this thing simply, and you can copy from earlier code. So here I can paste that. So output path is this one, and check result df, so that we need to fetch. So row level outcome is stored in this data frame, which is basically dynamic data frame in Glue, and that we need to convert to Spark data frame. So we can use 2df. Okay, let me make this little bigger for your easy visibility, and then we are writing the data. Okay, now in this case there is a catch that when you are writing the data, because we are adding some new columns and there might be some comma available within that column, so it is better to not save the file or data frame as CSV, rather we can follow any other format, maybe Pydeequ, etc. Okay, so check result df dot repartition. So I will remove this, and then here I will give Pydeequ. Okay, and Pydeequ file don't require separation, so I will delete that, and that way the data will be written in this particular S3 location in Pydeequ file format after the data quality check. Okay, right? So pretty much the code is same, and I'll save this. So this way we have written a Glue data quality check pipeline, which will read the data as a Spark data frame, then convert to Glue dynamic data frame, and then apply that evaluate data quality checks, and then it will finally convert back again to Spark data frame, and will write the data in Pydeequ file format in our S3 location. Okay, so now it's time to test it out. So the job is saved. I will go to the run section and I will click on run. Okay, so that the job is running. Till then, let's just reiterate what are the issues available in this file. So here if you see that first issue available is petal length. Petal length negative value not possible. So this row ideally should be throwing error. And we are considering ID column as unique. But here if you see the last row, ID column has duplicate. So this row will also should fail. Right? So let's see whether it will fail or not. So here the job is succeeded. So let's see in the validation output, if we go, here we will be having a Pydeequ file. So let's download that data and let's inspect what we are getting. So for this particular Pydeequ data inspection, I will be using an online Pydeequ viewer. So if you search online Pydeequ viewer, here it will be the first thing you can go, and then launch web app, and here choose the file. Okay. So here this is our Pydeequ file. I'll open this one, close this one. Okay, and here you can see ID, sepal length, sepal with petal length, petal with class name. This was available in our input data frame also. Apart from this, here you can see we are having some specific columns like data quality rule pass. This is basically indicating one particular row has passed what all data quality rules. Okay, and what all data quality rules failed for a particular row, that we will be getting in this one. And here if anything is skipped, that will be showing here. And data quality evaluation result. If for any row a single data quality rule fails, then this status will be changed to fail. Okay, so let's just take it failed, FAILED, and here you can see there are some rows which is failed. So if I scroll completely left, you will see 149, 5.3, 3.7, 1.5, 0.2 ID6, and then 149, 5, 3.3, 1.4, 0.2 ID6. So this is nothing but this particular row. Basically the data quality check failed, and which one failed? That ID column should be unique, and that if you want to check for these rows which data quality check failed, if I scroll right, here you will be getting in this fail column, here you will see is unique ID. That means these checks failed for this particular row, right? Then one more data quality check ideally should be failed, and that is this petal length. So here you are having negative value, right? So let's see where it failed. So I can maybe copy with -5.1. and here this is the row. If I scroll right, but here we are seeing no data quality check is failed. Why so? The reason is, if I go to my code, the reason is available here. So what happened that because we have not given infer schema true, that's why Spark considered all the columns for this data frame as string data type. And here we are applying a logic column value petal length greater than equal to 0 or greater than 0. String greater than 0, this comparison itself don't work, right? So we need to provide that check also, option infer schema true, right? And in that case, the petal length column will be considered as double or float data type, and then it can apply this particular check properly. And because we are having wrong data or negative value for petal length in this row, so it will also fail. Okay, so we'll save this one and run this one to check what is happening. So I'll click on run button. We can go to the run section and we can see our job is running. Let's wait for a few seconds till it get complete. So here the job is succeeded, and earlier we were having only one file in this output location. If I refresh, one more file is there. This is the latest one because it is last modified. So I'll download this one and let's inspect in online viewer. So launch the app and we'll refresh and I'll choose the file. So this is the latest file. I'll click on open, close this. I will search with failed, and now we can see there are 3 failed instances. One was earlier where due to uniqueness issue the ID column was failing, and that we were getting. Along with that, now this time petal length greater than 0 also failing for this, right? So this is the beauty of Glue's data quality check transformation, because it not only detect the data quality issue, but it shows in which row what check is failing. That is its beauty. Let's check for one more case. Here I'll open this file, edit with Notepad++, and here also we are having this minus 5.1 issue in the petal length. Apart from that, here we have these 2 rows where ID column was having issue. Along with that, we added one more issue in the petal length column also for the same row where ID column is having issue, and that is minus 3.4. Okay, again petal length is negative in this case. So let's see what will happen when we will apply the Glue data quality check here. So here I will upload it. So this uploaded, set 3, and this is the S3 URL. I'll go to this script. Now at this one, and all I need to do is change the input path. Okay, and then click on save. Please update it, and I'll click on run. Okay, so here the job is running. Soon we should see that one more file will be written here, and we should inspect. There should be this issue also highlighted, that not only in this row ID column is not following that uniqueness criteria, but here petal length is also having negative value. So that check should also fail, and here we should be having a new file once this run is complete. So let's wait. So here the job is successful. Now here we can go back to the output location, and this is the latest file. So I will download this one, and then here I will go to online Pydeequ viewer. I will refresh the screen, and I will choose the file, this latest one, and I'll close this, and then here I will search with failed. Okay, right? So here you can see that this particular row 149, this one failed due to only uniqueness issue in the ID column, because there is no negative value in other petal length, or class name is also coming within ID status. So here if you see in data quality it will fail, only his unique ID is detected because that only failed. But if you check the another row, here petal length is having negative value along with ID is having duplicate value, right? So both data quality check failed in this particular row. And here if you check data quality, it will fail column. Here both are detected. Okay. So this particular Glue ETL transformation data quality check not only tell you whether a data quality check success or failed, but it will also highlight that particular row and what all data quality check failed. And here if you check the pass column, so here class name complete, that also satisfied because class name is here not null, and the class name within ID is Virginica ID status, and that also got satisfied, right? And obviously along with these 2 field, we are having one more field where this row earlier also we have seen that due to negative value in the petal length column, right? So this is available as column hello petal and greater than 0. This particular condition is not satisfied. I hope you got it, and especially after going through the detailed PyDQ session, I hope this particular drag and drop based data quality check approach is very simple, because we already understood what is the importance of is unique, is complete, then in clause, right? And after going through all those coding sections, I hope this drag and drop based data quality validation is very much simple to you. In our next section, we'll be exploring some more interesting data quality checks and the transformations in AWS Glue. Stay tuned. Now in this particular section, we are going to explore another very interesting data quality check, and that is with respect to joining data from multiple sources. Okay, so for this particular data quality check explanation, I have taken two data sets. One is employee.csv, one is department.csv. So in employee table, here we are having employee ID, employee name and department ID, and in department table we have department ID and department name. And suppose we need to compute that this particular employee is in which department, what is the department name, then in that case what we'll be doing, we'll be considering this particular employee table's department ID as foreign key and this department table's department ID as primary key. On top of this we'll be doing a join. Then in that join result we can take the department name from this right side table and we can easily understand this employee is from which department, right? Now, this primary key foreign key relationship sometime we might need to validate. For example, let's consider here we are having another entry that employee ID 5 and then the name is, let's consider MS, and the department ID is 11. Now, if you want to check what is the department name, you might have gone to the department table, but here with 112 department ID, there is no such department. So that means this particular row has some wrong entry, because it is not possible that one employee is having such department ID which is not itself available in that organization, right? So this kind of primary key foreign key relationship we might need to check in some specific use cases, especially when we are doing joins. Now this kind of data quality, how we can validate that whether for all the foreign keys the values are available in the primary key for the another data set. So that kind of check we are going to implement today in this video. So as a first step, what I will do, I will upload both dataset in our S3 location. So here I have just selected them and here I will click on upload, and it will be a very simple operation again because Visual ETL simplifies the whole process as we discussed in our previous section as well. So click on Visual ETL and here we need two S3 data source first. So search for S3 and here I will be choosing two source. One is this, maybe for employee table, another one is for our department table. So here I can give the name as EMP data and this column name as DPT data. Okay, and employee data, for that the data is uploaded already. So here I will open this in a new tab and here I will be copying this S3 URL and it will be pasted here. Okay, so employee data is done. Maybe if you want, you can choose this as CSV file format, and for this DPT data here I'll be taking department.csv. Copy this and paste here, right? So here also CSV file. Now both data sources are done. I will select our employee data source and with that I will try to relate our evaluate data quality. Okay, cool. Now for this data quality evaluation, not only employee data should be input, but we want input from the department data also, kind of to check whether in that employee table whatever columns are available in department ID, those are available in department dataset also. Now click on evaluate data quality. Here you will be getting that both of these data sources are input for this, and here you can see already it has selected the employee data as primary dataset. So in this employee dataset, whatever values will be there in the department ID, that we want to validate in this department ID dataset, right? So department ID kind of a different dataset in which we want to refer whether our employee dataset is having correct data or not. So let the department data as only reference data. So I can give as reference data set. Okay, right? And then here if I scroll below, we can search referential integrity. Okay, and here we'll be getting an option. let me show you some example. We can expand this particular section, and here you will be getting the details. Like for example, I can click on the rules and then click a simple plus icon. Okay, so here you can see the example what it has shown. Maybe in our primary dataset we are having city and state, and that we want to check whether in reference datasets, reference city and reference state column, all those informations are available or not. So in that case we can apply the logic like this way. But in our case we don't need to compare city state, we need to compare only one, that is department ID. From the primary table, department ID, whether it is matching with reference datasets. Okay, so here it is not reference, it is reference dataset. There we are having this department ID column. With that we want to validate. So if you want to validate multiple columns, then we can put within curly bracket, but I am having single column, so I will just put as is. Okay, right? So this is our data quality check in this case. Referential integrity, department ID from this primary data is having all the informations available in reference dataset department ID or not. So equal to 1 I am putting because we want 100% match. Okay, right? Because there should not be a single row in the employee table which is having department ID which not even exist in department dataset. Now here what we can do, we can scroll below, we can check original dataset, along with that if any error occurs for a row, that also I want to get as a separate column, right? And then as part of the last step, we can put S3 target for this particular step output. So I'll select that step, and here I will search for S3 and S3 target I will click, and here our framework is done. Okay, so now what we can do, we can directly go to the script section and we can edit this script. I'll confirm this, and here employee data, department data we are reading as Glue dynamic data frame, but as I told you in our previous video that infer schema might be needed, which option is not directly available here. We might add with some other properties, but let's consider we are very much comfortable with Spark. So no problem. Once you get this kind of code, all you can do, you can comment these two codes and put your Spark code based on requirement. So here I can put like this way, employee data equal to, and then I can read the data from this S3 location directly. So already in our previous video we have done this step, so I will copy that from there. So I'll open AWS Glue in a new tab, and here this is the one which we used in our previous video. So here this is the way how we were coding, right? So I'll copy that, and here I'll be pasting that. Okay, so input path 1, and here we'll be copying this employee dataset path and paste that here. Okay, and here I can give emp dataset equal to spark.read header true, keep all these things as it is, and csv file input file 1, this one we want to do. Okay, and that dataset will be passing here. Okay, right? So that way from this employee data we have created a Spark data frame, and that one we are converting to Glue dynamic data frame. Okay, maybe if you want you can keep that same data frame name what Glue generated from Visual ETL, right? So that way our this job is done, and we'll be copying that same code, we'll be pasting that here. It will be input path 2, and here we want to read the department data, so I'll copy that, and here I will paste it, input path 2, and this is department dataset, and that one will be putting that here, and department data node name was this one, so we'll be just using that same. Okay, so that way here we are reading the employee dataset, here we are reading the department dataset. Then let the Glue logic apply. Again, while writing the data, we will convert back to a Spark data frame and we will write it, because here you can see by default repartition 1 is not configured, so it might generate multiple files, but we want all the response in a single file, and maybe I am very much comfortable in writing Spark data frame based code. So that time all you need to do, just convert the Glue dynamic data frame to Spark and use the Spark code like we did earlier, right? So here this is the code, I'll be copying that, and here I'll be pasting. So this is our Glue data frame, so that I will be pasting here, right? So first we will be converting Glue dynamic data frame to Spark data frame, and then we are writing the data in Parquet file format in this output location with repartition 1. Okay, and in job detail we can go and change reference check something, and IAM role we can configure Glue service role, and keeping all other properties default, we can save this. So it is saved and we'll click on run. Okay, so we can hope that this code will run properly, but there is an issue, I guess. Dynamic frame we have not imported, so the code will fail actually. So dynamic frame we need to import, and we'll save this. We will pause this earlier run, so let it get stopped. This currently in stopping stage. Let's wait for some time till it gets stopped. So it is stopped now. We can run it. So here it is throwing concurrent run exceeds reference check. So maybe in the backend it is not yet stopped. So either we can increase the concurrency or wait for some time to make the job runnable. So maybe I can go to the job details, and here maximum concurrency, I can change this value to 2 and save this, and I'll go to the run again and I'll click on run. Okay, so here you can see our job is started. Let's wait for a few seconds. If we don't get any error, then again in our output location, this reference integrity output we should get. So let's see. So here currently the job is succeeded. Now here we can go to the output section, refresh, download this particular data, and we'll inspect with online Pydeequ viewer because it is a Pydeequ file, directly we cannot understand. Choose this, and we are getting this data set. And here you can see that for no rows in the employee data set, the data quality rule failed. Okay, because for all these rows, the department ID is available in our department data set already, right? But let's consider if our input is like this, that here we are having one employee called Eric, whose employee ID is 5, but he is having department ID 105. And with department ID 105, in the department table, we are having no rows. So let's see what will happen in this case. So here what I will do, I'll upload this file in this input. So employee issue, and here click on upload. Go to input file and then employee issue.csv. Copy this S3 path. Go to the script location, and instead of employee.csv, we'll be putting employee issue.csv. That's all. Save this, and then here once it is saved, we'll run this job. Okay, so this time what should happen? It should clearly show me that for these 4 rows there is no issue, because for these foreign keys in department ID column from employee table, there is reference available in the department table department ID column. But for this row, it should throw the issue in the data quality check failed column, that for this row, the department ID what it is showing in employee table is not available in the department ID column in the department table, right? So we'll inspect that. Let's wait for a few seconds until the job gets complete. So now the job is successful. Let's go to our output location, refresh here. So this is the latest file. I'll download it, and here I will inspect using online Pydeequ viewer. Choose the file, click on open, close this, and here you can see for the department ID 102, 103, 101, there is no information available in data quality rule failed because none of them is failed. But here for Eric, the department ID is 105, and here you can check clearly it is showing in data quality rule fail that this particular data quality check is failed for this particular, right? And that is obvious because you intentionally failed it. And the status, if you check, although rest are passed, this is failed. So this way you can perform referential integrity check. And I hope you are clearly getting this. This will be very helpful, especially for doing join operation. And in our most of the data pipelines, we are having join operation with various data sources to enrich the data. And not only equal to 1, you can do some other comparison also. That is, from the employee table, the department ID should be available at least 60 or 70% in our department table, department ID column. Those kind of comparison also you can do. And for that, you can refer this AWS blog. Let me show you some example. Like here, if I scroll below, here they have given this kind of comparison. Like reference integrity between column A and reference tables column A between 0.4 and 0.6. That means 40 to 60% match is okay, right? Like this way also you can perform referential integrity check. And apart from that, there are some more advanced data quality check also available in this blog, which I clearly explained. Obviously, you can go through this and the AWS documentation to explore much more about the AWS Glue data quality transformation and PyDQ. So this is all for this video. I hope this video has given you a clear picture on implementing data quality checks in your data pipeline to improve the business decisions with the correct data and rectify the data lake data whenever there is some issue coming from the source systems. All the codes and the required links I'll be sharing in the description box of this video. Go through those, try to play with it, and that way you'll be understanding better way about this concept. So this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.